So I'm going to start now the presentation of AI meets IoT, Industrial IoT on the Edge. I'm Daniele Cleri, AI and IoT software architect for AAEON Europe. AAEON is the industrial IoT company of the ASUS Group. We are a worldwide industrial PC company for the last 25 years. We are growing fast and stronger every year in Europe, but we have presence worldwide, expertise on standard form factor, but also customization, and we develop from board to full system solutions. We are committed to innovation, as you will see also from this presentation, and we have a strong focus now on AI and industrial IoT. I'm not going to bother you much more on company presentation. We will go straight into the big topic of this presentation. IoT, big data, analytics. Those buzzwords are around for many years, and I think most of us already know what they are about. IoT, so Internet of Things, collecting and storing data, taking actions on edge devices. Big data, the collection of all this information in the cloud, and keep increasing and storing much more data in the cloud to then reuse it for analytics. Analytics is the last part where all this data is taken into account, and different services that are already available enable the companies to use this data collected by IoT devices to take decision. So analyzing IoT-generated data improves the decision-making, and it's improving decision-making of software solutions that are already available in the market. This kind of approach is difficult to manage, especially because the great amount of data and the software tools still are lacking one important part, because the decision still needs to be taken by the people. And with so much data, so much different situation, you cannot always address every kind of option that the system is facing. So how do we handle that? How can we solve this problem of improving the decision-making process? The decision-making process is, for example, enabling the access of a certain security area, or responding to a malfunctioning of certain devices. If we do it using just the standard approach with data we collected over the years and analytics, we may miss some of the situation which can change over the years. And that's why we are now moving with the new technologies from a solution driven by just analytics to AI-powered decisions. So we are transforming the decision-making process from analytics to AI. And right now, AI is mostly used and known in cloud services. We all know Siri, we all know Google Assistant, and there are many other options in the cloud that are using artificial intelligence, centralized artificial intelligence in the cloud, that everybody can use. And to use that and to provide data, we need to connect and to provide information to the cloud. And this approach is not always viable. It's not always valuable, and it's not always the best option to manage the information and the decision that are interacting in the whole system. That's why we are now moving from a centralized system into a distributed system. And as you can see from the picture here, the complexity of the solution increases. So why are we now moving from a centralized system into a distributed system? We are doing that because we have so much power and we have so many edge devices that they cannot just be used to collect data and to recover the information and act. They can actually be used in the process of the decision making. And that's why now, before in the cloud and now in the edge, this process is happening of distributing all the decision and all the information to edge devices. So what is happening is that we are breaking down the AI computation that today is all happening in the cloud into two parts. AI is comprised of a part for the training, where there is a process of the machine to learn about a specific situation and from existing data. And there is a second part, which is called inference. And with the inference, we are applying this capability to new data. For example, we are training a system to recognize a voice, and then we are trying to say some new phrase to the system, and the system automatically recognizes what we are saying. To do that, we have to use the training in a place where we can actually crunch a lot of numbers, because the training process is very power intensive. And so far, and also for the near future, that will happen mostly and or only in the cloud. The inference, instead, it's a process that can be also moved a bit further down from the cloud into edge devices, moving first into workstation. Most of the training is happening on GPUs, and the same also, most of the inference is happening so far on GPUs, and that's where also can be done on workstations that are closer to the edge. So we are moving towards a distributed AI. Still, we are not there. We have data centers, we have workstation running inference, so taking the decision not in the cloud, so closer to the sensors and the devices. But that's not enough, because the decision-making process, if not running on edge devices, is still having a few problems. In particular, if we are not running on edge devices, we have a problem of latency, we have a problem of reliability, of security, and of scalability. So with our program App AI Edge, we are trying to bridge this gap between AI in the cloud and moving that into an AI distributed system on edge devices. So reaching the zero latency to increase the security. How do we increase security? For example, in vision application, usually to recognize a person, we have to record a video. And when we record a video, we are recording information that are sensitive. And for example, even with the GDPR, there are a lot of problems to share this data somewhere else or with someone else. If we have a decision-making on the edge, with the artificial intelligence application running on the device, we don't need to move this data. So we already can secure much more easily, this information inside the edge device without need to worry where this data is going, because it's not moving. Reliability. What happens if one device fails on the edge? Only that specific part of the application is not working anymore. So still, the rest of the system that's using a distributed deployment can still work, and we can still manage to run our application across all the other devices. If we have a centralized system, even if it's distributed in the cloud, there could be a serious connectivity issue that will block completely the system from working. With the distributed with the distributed AI solution running on the edge, even if the connection is not working, your solution will still work. And of course, the scalability, because even if the cloud can scale indefinitely, there's still a problem then of moving the data, moving the information, sending the video from the device to the cloud. That's always a very expensive process. And if we are increasing now resolution of cameras, if we are increasing now the number of cameras connected or other sensors, this becomes even more a problem. So how do we meet AI and industrial IoT on the edge? These are our industrial gateways that we are manufacturing, and they're products that are already certified with the red certification in Europe. They are based on Intel technology, Atom processor, Apollo Lake generation. All the gateways have support for a various range of wireless technologies, LoRa, Bluetooth, Wi-Fi, LTE, and also IQRF wireless. We have the indoor gateway that you can see on the left, and the same one that's actually in a IP68 enclosure on the right. Both these, they are not only powered by Intel Atom processor, but they integrate a specific module called AI Core X. AI Core X is a module that enables edge devices to run efficiently and in a low power inference application. So we can run now on edge devices that are already executing IoT applications, reading from sensor, actuating devices, also running inference application without the need of upgrading our system into more expensive and power-hungry solutions. So the AI Core X family is actually including a different number of products. What we have here is a table that summarizes all the products that we developed so far. All the AI Core X family are based on an Intel Movidius Myriad X chip. It's a vision processing unit that is able to run the inference on its chip, and it offloads the main system from running inference. So the main system still can run any kind of application, while the AI inference is running on the offload unit with the AI Core X module. We have a full-size mini PCI Express module with the one Myriad X, and also a module in M.2 form factor. And then we have a solution with one or two Myriad X chip, still with the M.2 form factor, 2280. We have a specific modules for one of our system called AI Vision Plus X, which is compatible with our system on module AppCore Plus, which provides 3 Myriad X chip on board. And at last, we have a PCI Express module that can carry up to 8 Myriad X modules. All these products are compatible with the existing software provided by Intel. They don't require additional drivers, and they all are possible to integrate into our product. In particular, the first one that you see, the AI Core X on a mini PCI Express form factor, is the one that's included in our IoT gateways, both indoor and outdoor. You can find more information also about the gateways from industrialgateways.eu, where you can see all the specifications. The system have up to 8 GB of RAM, 128 GB of eMMC, and of course, expandability with SATA and other I/O, low speed like GPIO, I2C, SPI, but also high speed like USB 3, HDMI, DisplayPort, and Gigabit Ethernet. So how do we exploit the power of AI on edge devices? As we mentioned, the indoor gateway and the outdoor gateway that we have includes multiple units, multiple processing units. We have a CPU, we have a GPU. Some of the units that we have, they also have an FPGA, and of course, because they include the AI Core X, we have also VPUs specific for AI inference application. But in theory, any kind of the processing unit that we have on edge devices can run inference application, because we can execute TensorFlow application also on CPU or on a GPU, like we are doing already on the cloud systems. Now, edge devices are already running IoT applications, so we have to be aware of the workload of our systems, and some of the resources, they cannot be used because they need to be used for other applications that are running on the system. So to summarize, these edge devices become now quite complex, heterogeneous system, which makes life much more complicated to manage, in particular, to take the full advantage of all the computational power that we have on the edge. So how do we do that? How can we optimize the way we can use the available resources on edge devices? Usually, to program for a specific unit, CPU or GPU or FPGA, we need specific expertise. So there are developers that are more focused into GPU programming, others that knows how to program FPGAs and how to use FPGAs. And also depends on which units are available, depending on the IoT application that's running on the system. So to do that, we need the help of software tool that can simplify our life, that can manage this complexity for us, and that can just decide what is the best processing unit to use, depending on the use case. This will enable us to use all the power of our Industrial IoT edge gateways. And thanks to the Intel OpenVINO toolkit, now it's possible to develop application and solution that extend all the workload across all the units that are available on the system. So without expertise of a specific processing unit programming, we can easily develop a generic AI application and test and deploy the application on one or multiple processing unit that is available on our edge devices. For example, we can run a face detection algorithm on a CPU, and we can run our recognition of what is the person doing, or what is age or the gender of that person using the VPU. And for example, we can leave the GPU free because maybe the GPU is running a display signage application. So with this toolkit, we can leverage all the power that we have on the edge system, and without the needs to know the programming of each specific unit that is available. Of course, the toolkit provides already CNN that have been optimized for Intel architecture for all the processing units available from Intel. So CPU, GPU, also the MyriadX and FPGA. And all these units can be programmed with the common API. So it's going to be very easy for developers now to work on complex applications of AI. This is a landing page that is also being updated recently. As you can see, this is Intel Software Developer Zone with our App Square AI Edge Gateway. The App Square AI Edge Gateway is part of the AI Vision Developer Kit that enables you to explore and test and develop solutions based on Intel technology using OpenVINO to take full advantage of the power that an edge device like this can provide. You can already buy the kit online, or also you can go and visit the developer zone of Intel so that you can see the characteristic of the system, which includes also a camera. And the system comes pre-installed with Ubuntu and, of course, OpenVINO and Intel System Studio. So it's ready to go for you to start developing your AI applications. Now, with the AI application comes also the complexity of merging AI with existing or new IoT applications. Because when we are talking about IoT applications, we have a situation where the communication happens not only between the device and the cloud, but also between devices. And the different applications now running on the edge device are now sharing information. Because if we have taken the decision on the edge, we are not sending data to the cloud and waiting for a response. There is an application running as a collection of data from sensors. There is another application analyzing this on the edge using AI inference application. And after analyzing, we are taking action. So there are one or more other applications that are taking action on the decision made by the edge system. And once done, also, we have to share this information with other devices. For security, we might need to block the access of a certain area. So the device that's taking the decision needs to alert the other device nearby, for example, to block the access. So all this complexity, also on the IoT, needs to be managed to take the advantage of intelligent distributed system. And to do that, we have to find a way to modularize the approach of our applications. So from a single system that's running one operating system with many applications, we can move into running different applications for different purpose in separate units that we call containers. Containers is a technology that in the last few years came more interesting and has been used mostly in the cloud, but now is also started to be used a lot also on edge devices. In a similar way to virtual machine, we can isolate applications. We can put these applications side by side and run on the same system. And those applications, they can be easily managed, but they don't interfere with each other. So it's going to be much easier to manage, deploy, and also let the different applications to talk to each other. Docker is the most common one, but you can find online there are many others, containers, technologies. In particular, we are looking at Docker because it's the base technology used by one of our partners. In order to manage huge applications running on many, many devices, we need, of course, to containerize, to modularize our applications. But we also need to manage all these devices. And in order to do that, the software company Balena is providing a service called Balena Cloud, based on containers technology, that helps you to manage, to deploy, and to develop and to maintain a fleet of IoT applications. And you can manage that from everywhere in the world. This software solution is comprised of different open source applications. We have the Balena OS, which is the host OS of edge device. It's based on Yocto. It's a very basic system that enable all the functionality of the device. It helps the system to communicate with the cloud system in a secure way via VPN, and also is also developed in a way that the system can be upgraded securely. The other component is OpenBalena, which is the building blocks of the cloud server, which is, of course, used to manage the whole fleet of your devices. Then we have the Balena engine, which is a container engine. So it's the application that will run your application on the Balena OS. So all these components that are open source are integrated into the Balena Cloud solution, and that can be used to develop and maintain your AI IoT applications. This is an example of what you can see from a dashboard of this of the Balena Cloud. This is just a simple dashboard where you can see all the devices, all the applications that you have developed and that they are deployed. It's very simple and intuitive. It supports a wide range of devices. All our gateways are already being validated with the platform. You can easily create a new application. You can manage a group of applications. And you can monitor, update, configure, enable, disable, and run multiple applications directly from this dashboard. The service comes with 10 devices used for free. And then if you scale, of course, there is the option to go with a paid service, or you can use the open source server and create your own management system based on the same technology. Now, to demonstrate the AI and IoT technology, we are showcasing some demos in our booth. and which is in all number 1. And you can see particularly this one, which is an open source project from one of our collaborators of the community, the app community. It's a robot based on App Squared with the Atom X7, Intel RealSense, and of course the AI Core X. It is an autonomous robot that can drive around and map the area and also interact with the people, avoiding obstacles, and also some features to detect objects and people. So it's a great way to show what you can achieve with these applications. And it's all running autonomously without a connection to the cloud. We have also another application running on AppSquare and AI Core X. It's a drone developed by the software company AAEON. This drone can identify objects, and you can follow the drone from dashboard remotely, and that drone can trigger alarms from picture and situation that are analyzed during the route that is taking. So this solution can be used, for example, in industrial environment where you need a surveillance system. And last, we have another AI IoT application based on the IQRF wireless technology. We have an AppSquare gateway running the Logimic OE gateway software solution. As you can see, there are many wireless sensors which helps the system to detect different situations from the number of people that are in the room, temperature, and then we have lights control, temperature control, etc. And depending on the situation that we have in the room, number of people, male, female, or any other situation that like temperature, time of the day, time of the evening, the system can automatically adjust the temperature, can adjust the light system, so it optimizes automatically the power use and the lights, and also the usability of the room for the people that are there, without any other complex logic behind. So there is simply a trained AI application that's taking the decision on how to manage all these sensors and actuators. And that's all. Do you have any questions? Yeah. The kind of processor of the gateway that we have there, it's an Intel Atom X5 and X7 processor based on Apollo Lake, a quad-core processor up to 2.5 gigahertz, 8 gigabyte of RAM, and 128 gigabyte of eMMC. They are, of course, x86, 64 bits, so you can run a standard operating system. Our gateway, all our gateways support different kind of Linux distribution, Ubuntu, Debian, Yocto, of course, but also Windows, Windows 10, and Windows IoT, and Android. Any other questions? Sorry? We don't support officially FreeBSD, but if you
do not support FreeBSD, OpenBSD, and NetBSD. That's my
not
question.
officially, but because we have also a community support for our platforms. There are many users that already enabled FreeBSD and OpenBSD. For example, also pfSense has been already enabled and tested on our platforms, so you can use pfSense reliably. It's not officially supported by us. It's a community support project. But of course, in case of specific projects, we can work together with the customer, with you, to provide the specific support for that platform. Okay?